In this video, we're going to solve this problem on motion of a particle using Newton's second law of motion. All right. A particle of mass 5 kg, which was initially at rest, is acted upon by a force 7t plus t squared newtons at the time t. We have to find the velocity and the distance covered by the particle after 3 seconds. Newton's second law of motion states that the rate of change of momentum of a body is proportional to the applied force and is in direction of the force. So momentum is mass times what? Velocity. That's the formula for momentum, the product of mass and velocity. So mathematically, we can summarize Newton's second law of motion as the force is directly proportional to the rate of change of momentum. That is dmv dt. The law says the rate of change of momentum of a body, all right, is proportional to the applied force and is in direction of the force. So F, which is the force, is proportional, directly proportional to the rate of change. Rate of change is to differentiate the momentum with respect to time. Now, the mass of a body is constant. Yes, it is a constant. We have to eliminate this proportionality sign by introducing a constant. Okay, so since the mass of the body is a constant, if we bring it out, all right, we'll be having F equal to the mass of the body times dV dt. This is what we are going to make use of to solve the problem. Now, the force is this, all right? The mass of the particle is 5 kilograms. We have to find what? The velocity. We can get velocity from here, dV dt. Let's go ahead. F is 7t plus t squared, 7t plus t squared equal to 5 dV dt. You get it? So, if I divide both sides by 5, I have 1 upon 5 into 7t plus t squared equal to dV dt. This is a differential equation. So to determine v, we have to integrate both sides. So let's separate variables before integrating both sides. This is a function of t. So if I multiply by dt, I'll have 1 over 5 into 7t plus t squared dt equal to what? dV. So integrating both sides, that's the integral of 1 over 5 into 7t plus t squared dt equal to what? The integral of dV. 1 over 5 is a constant, so 1 over 5 comes out. We have integrate 7t with respect to t, that's 7t squared upon 2. Integrate t squared with respect to t, that's t cubed upon 3. Plus c, that's the constant of integration. Integrate the v, that's what? V. So v is 1 over 5 into 7t squared upon 2 plus t squared t cubed upon 3 plus the constant of integration. So let's determine c, which is the constant of integration. Now, we need to get the value of the constant of integration. To get the constant of integration, we need a value for velocity and a value for the time. But the question says that the particle was what? Initially at rest. Initially at rest, that implies that the velocity is 0, right? And the time is also what? 0. So t is equal to 0 and v is also equal to what? 0. If I plug in 0 for t and I plug in 0 for v, I will get 0 equal to c. Yes. If I put 0 here now, 0 plus 0 is 0. Everything in this bracket is 0. In fact, everything here is 0. If I plug in 0 here, that's 0. So v equal to 0, t equal to 0 will give us c equal to 0. So c is also equal to 0. Alright? It is very, very clear that c is 0, given that t is 0 and v is also 0. So therefore, the velocity of the particle at any time t is 1 upon 5 into 7t squared upon 2 plus t cubed upon 3. This is it. Now we are to find the velocity after what? 3 seconds. So at t equal to 3, v is equal to 1 over 5 into 7 over 2, plug in 3 for t, 3 cubed upon 3. That's 1 over 5. 3 squared is 9. Okay. 9 times 7, that's 63. So we have 63 upon 2. This is 3 cubed, which is 27. 27 divided by 3 is 9. So expanding this bracket, we have 63 over 10 plus 9 over 5. This is over 1, so 5 times 1 is 5. Alright, the LCM is 10. So we have 63 plus, that's 18. Okay, 63 plus 18, that's 81. 81 over 10. 81 over 10 is 8.1. 8.1. So we have 8.1 meters per second. So the velocity of the particle after 3 seconds is 8.1 meters per second. Now, what is the distance covered by the particle at the same time? Velocity, recall, is ds dt. Differentiate distance with respect to time to obtain velocity. Okay, now this is the velocity equation that we got. Okay, so I can say ds dt is 1 upon 5 into 7t squared over 2 plus t cubed all over 3. Yes, so I'm writing this in place of this now. So this is a differential equation. Separating the variables, we have ds is equal to 1 over 5 into 7t squared upon 2 plus t cubed upon 3 dt. So if I integrate both sides, the integral of ds is the integral of 1 over 5 into 7 over 2t squared plus t cubed all over 3 dt. Alright, this is s. 1 over 5 is a constant, so 1 over 5 can come out. We have, let's integrate this. Okay, so if I integrate 7 over 2t squared with respect to t, this is what I will get. 7 over 2 is a constant. Okay, so integrate t squared dt, that's t cubed. Then I'll multiply this one by 3. You get a lot of integration. Plus, this is 1 over 3, the coefficient of t cubed. So integrate t cubed with respect to t, that's t to the power of 4 divided by 4. That 4 will multiply this 3 here, plus the constant of integration. So s is equal to 1 over 5 all into 7t cubed all over 6 plus t to the power of 4 all over 12 plus c, which we can write as 7t cubed all over 30. That's we are multiplying the bottom now by 5 plus t to the power of 4 all over 60. 5 times 12 is 60 plus c. Using the same initial condition, that is t equal to 0 and in this case s equal to 0. S equal to 0. Okay, so that we can get the value of c. S is 0, t is 0. So 0 is equal to, everything here will still be 0. 0, 0. That's 0 plus c. And this implies that c is equal to 0. So the distance equation is this. 7t cubed all over 30 plus t to the power of 4 all over 60. So this is the distance covered by the particle at any time t. So after 3 seconds, when t is equal to 3, the distance is 7 over 30 into 3 to the power of 3 plus 3 to the power of 4 all over 60 in meters. So what's S? This is 27. That's 7 over 30 times 27. Okay. Plus 3 to the power of 4 is 81. 81 all over 60. Okay, 3 here is 10. 3 here is 9. 9 times 7 is 63. 3 here is 27. 3 here is what? 20 meters. So the distance after 3 seconds is this. The LCM is 20. Okay. So this is 20 divided by 10 is 2. 2 times 63 is 126. 20 divided by 20 is 1 times 27 is 27. 126 plus 27 is 153. Okay, in meters. That's 153 all over 20 meters. So if I divide that by 20, I'll get 7.65 meters. So this is the distance covered by the particle after 3 seconds. Okay, so this is it for this particular question. All right, keep supporting, subscribe, like, and share this video to your friends and your classmates.